Zolner. I'm one of the founders of Bricasti Design, and the company's based in Massachusetts, in Boston, and that's where I live. I'm from New York, and we're here to show our new M28 power amplifiers, and of course our M1 DA converter with its latest upgrades for DSD. A lot of content available that was done for SACDs. Now there's some things for download, and the product, we should be able to allow our customer to play back any kind of content, whether it's 44.1, 192, DSD. So it's a matter of offering that to be available as a source for music and content. So you have to get out of the philosophical discussion and get into the reality is that that's out there. Let's do it, and if we can do a very good job of reconstructing that data, then the customer will be happy. I would say more than 99% of the content is 64. 64 is the SACD standard. So there's very, very little at 2x. In order for us to do the higher rate, we're working on that right now. We're going to have an upgrade to do that because we had to make a hardware modification to get that data rate over the signal path in the unit. So essentially, there is a filter. And although I didn't want to bring that out because people tend to believe there shouldn't be. What we did in the M1, which I think is quite unique, is we made a minimum phase filter for the noise. So there is a DSD noise filter, and it's done in minimum phase. And I decided not to even, and we already know, that the minimum phase filter is better than linear anyway. So why bother even putting the linear in? It's not a reconstruction filter like PCM. So it has a different purpose, but nonetheless it is a filter. And it starts around 30 kilohertz and goes more 24 dB per octave. So if you experiment a little bit with some different variations, the difference is very minor. So I just took it out of the user and made it easy, just play the stuff, You always have, first level of display is the input frequency. Second level is actually the rate that the M1 is running at. Because, this is a delta sigma device, which means we 8x oversample. So effectively, the M1 is always running at DXD, or 8x.
No matter it is
always runs
PCM.
It doesn't matter. It's already natively running at that. So when you run the DSD, I'll play something. We'll display, that's DSD1, so that it's running at 2.8 megahertz. So this is the status of things about. That's been going on for the past 15 years. That's how a modern converter works. It's by oversampling, and you oversample in order to create better filters. So now my filters coefficients are created at 352.8, not at 44.1. We haven't changed anything about the data. We still have to make a 20 kilohertz filter. We haven't changed the rules. It's just now when we create that filter, we have 8 times as many steps to interpolate the slope, right? So the solution, the benefit of that technique is to make better filters. So that's a win over a ladder DAC, which can't do that. So then you have a filter problem, right? So everywhere you go, it's a problem, right? You go one way or another way, and the industry moved on to this because actually it's a better solution than what you can do in a ladder DAC. It's just better, it's a better solution. And also, this type of converter is essentially can do you can run at any rate you like, up to DSD. So it's very flexible for playing all types of media. Is a 200 watt per channel monoblock. It's completely, it's a fully differential design, completely balanced. The whole, if you look at the structure of the amplifier, actually, this whole side panel, it starts out as a solid 3-inch block of aluminum. So the heat sinks are integral to the side of the amplifier. It's one solid block. So you have excellent thermal characteristics and temperature.
No need to put an internal fan.
No fan. The air. This is a ventilator. The convection runs. So the amount of mass in this amplifier, there's about 50 pounds of, 30 kilos of aluminum mass just in the structure of it. So that it gets, the point is that it's very thermally stable. And with this type of an amplifier, it's very critical to have thermal stability to get everything in balance, because it's an AV amplifier. And the amplifier also has adjustments in the back, a stepped attenuator, logic control relays, that you can, basically like a crude volume control, that you can take the input and attenuate it in 6 dB steps, because 6 dB equals 1 bit. So when you're using this as your front end, you don't want to attenuate too much. I mean, really, you really don't want to attenuate more than 24 dB approximately before you, then you start running into significant bits. But you got, so the idea is you have to be able to match the analog gains correctly. And most amplifiers and people's systems have way too much gain. Everything's attenuated. People don't realize that, but they have way too much gain. So ideal setup is, since the M1 has properly balanced output and unbalanced and proper line driving capabilities, I mean, the M1 will run up to 24 dB on the output, 6 volts. So it can drive anything. It's not just a DAC. It's really truly got a very good output drive section. I think the retail price for the set is $30,000.
Coming home now. I'm coming home now. I'm coming home now. Look down, Lord.